Thank you to everyone for coming to my webinar. My name is Tal. I've worked most of my career in capital markets technology and regulation before founding Dilla AI, an agentic platform and deployment company for financial services. Before we get into Dilla and agent harnesses, it's important to take a step back. After all, everybody here is a deal maker, project manager, capital markets domain expert. To get to the end goal of becoming an elite business developer, or at the very least, highly skilled early adopter of agents in financial services, we need to understand the basics. Now, forgive me if this is maybe too advanced for some or condescending to others. Everyone is at different levels technically, but you're all going to be getting really involved in this stuff in the next 18 months. So let's start with the absolute basics. The language of the internet. The language of the internet is JSON. Every time two systems talk to each other, JSON will be involved. JSON is a text format for structured data. It uses key value pairs. For example, open brackets, fund, KKR, AUM, 18 billion, strategy, private equity, close brackets. This is the standard way that software systems exchange data. Every key is a label, every value is the data. Values can be text, numbers, lists, or nested objects. When an LLM returns JSON, its output can be read directly by another system without any parsing or interpretation. That's why it's so useful in data pipelines, because the model's output becomes the next step's input automatically. So what I'm going to do is I'm going to show you an example, a practical use case of extracting structured JSON even from unstructured financial documents in the Dilla app. So I'm going to show you how this works. So let's upload a board pack for one of my portfolio companies in here. Let's just find it now. And let's give it to the LLM to process. Now, while this is going, this is obviously your first look at Dilla. It is the portfolio management section, which was the initial primary use case for Dilla. And here we have a venture/growth fund with a full ledger of basically ownership updates, amounts invested, valuation, etc., etc. So what should be happening here is the LLM is reading the unstructured document from the board pack and is turning it into structured JSON, to which it should upsert into the database. Let's give it a second for processing, because PDFs are certainly, while the language of financial services, they are the hardest documents for LLMs to process from a technical perspective, but it's where you can get the most value as a starting point. Without any agents involved, this is just a purely deterministic pipeline. So let's see what it comes up with. Okay, in the meantime, let's continue with our session. So the second concept that is essential to understand is function calling. Now, function calling is essentially an expression of logic in code. These are generally API calls like get or post, but they can be other expressions of logic that can be called or executed by a model. It could be something like add new company or get ARR. It is a method that, when ran, performs an action. In AI agents, function calls are usually known as tool calls. Now, there is a difference between them, but they're similar. The difference is the agent decides which tools to call and how to use the output of each tool. It may even be able to retry a tool call with a different input when it sees a failure mode in the initial call. When you're talking about automation, deterministic automation, we're usually talking about a selection of multiple function calls that contain technical and business logic. You may have heard of skills in Claude Cowork, and these are when an instruction is set in text for the agent. So it's slightly different, but they're all similar and adjacent concepts. Tools work similarly, except they contain actual methods to execute the business logic rather than just text instructions, and they have descriptions that the model sees before deciding which tool to use and how to use the tool. In many respects, the analogy fits. Think of an agent as an electrician fixing an electrical fault with an entire toolbox at their disposal, with the flexibility to choose the right tool and how to use them. Our final piece of the fundamentals is the basics on the LLMs themselves. LLMs ingest and produce tokens that, for the sake of this session, are priced at a quarter of a text character. The LLM is priced differently on tokens in and tokens out. For a workflow, we can predict the number of tokens we will need, as the flow is the same every single time. For an agent, decision-making is inherently probabilistic. Though we trust our agent to make the right decisions on which tools to call and adjust them when necessary. And here we have a practical example of the difference between a function and a tool call. And ultimately, yes, it just involves the agency of the model choosing. And that really depends on how many tools you expose to your agent, but more on that later. To truly scale as a wrapper business like mine, to put it pejoratively, a business must route models and assign token budgets per turn type. We want the best or the most suitable model for the task, and we don't want to spend a ton doing it. This is for cost reasons, but also for performance reasons. Context bloat is cost. Prompt bloat without caching. Prompt bloat is cost without caching. Cost without context is fatal. Token maxing is gluttony at the buffet, and we have to be surgical. What we really are looking for is, how does our agent build enough context to answer the question and perform the task with the right information there at its fingertips? When our agent runs, we see the tools it picks, we see how it executes them, we see what the tools return and how the final output is structured. And we route API calls in parallel across different providers. So And here we have an example of how precipitously context rots an LLM or an agent. So it's super important to be doing lots of this compaction, prompt caching, and all sorts of different techniques to keep that context compact and keep the agent's brain essentially working without too much clutter. One of the first magic moments I saw when using an agent was when it detected off its own back a task scope and flipped it into a task list and started knocking off tasks and just doing them and completing them and monitoring its progress. And this is what really takes the paradigm from assistant to agent. This is what we're really looking for in the enterprise outside of the coding use case. And we don't want to waste money on frontier models like Opus 4.8 or GPT 5.6, if you're actually allowed to use it. In the UK, we're not, to do it. So the question really lies, and yeah, so here we've got an example of the core difference between a deterministic workflow and an agent, with practical examples in Dilla that I'll show you in action in a second. So I guess the question really is, from your side, what should I use a workflow, as in a deterministic if-then with a few LLM steps kind of chain, or an agent that has the agency to choose? I personally think that's the wrong question. The reason why it's the wrong question is that essentially agents are just systems of multiple workflows, because the tools in the agent are essentially just workflows. And at a certain scale, when you've either got an agent with loads of different tools to choose from and loads of different modalities, you're going to be calling workflows anyway. So essentially, the basis of automation in financial services are workflows. But once we're doing it at scale, and once we've got enough automations for it not to just become a script or a chain, then that's when an agent comes in. And we also, what we really want from an agent is to be able to adapt, to be able to run asynchronously, so that's in the background, and also to be able to correct itself and steer course when it goes wrong. So these concepts are essential. And here we have an illustration of the context window, and this is what's included in it. It's the system prompt, which is the prompt that kind of tells the agent, you are a financial analyst at Goldman Sachs, blah, 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 blah. User message, self-explanatory, and then anything else that we're injecting into that agent from the previous step. So in Dilla, that would be, in portfolio mode, that would be the portfolio snapshot data, just to give it context, and then it will also pass it the data that's in view at that current time by the human. So before I show you Dilla, let's get into the agent harness, which is specifically what I actually came here to explain to you about. So to start off, I mean, what is an agent harness? An agent harness is anything in an LLM system that is not the LLM. So that can really include yeah, so the harness can include anything that's code infrastructure around the LLM calls. So that could be model routing, it could be prompt rotation, it could be caching, it could be conversational cadence, it could be routing for different tasks, tool selection and tool exposure, and rate limiting as an example. And some of these you may not be familiar with, but you're going to have to get familiar. In Dilla, there are 6 different modes with different system prompts, and each agent is able to reason across every domain. So it can reason across legal and then also go into the kind of financial analysis, for example, in the same run. And Dilla is essentially, it has 2 engines. The first engine is what we would call the workhorse. It's the conversational loop. And that's basically the agent loop, which deals with almost all of the queries and is designed for conversational patterns, and is designed also to do stuff, also to retrieve stuff, but it's specifically around this kind of conversational back and forth. The second engine of Dilla is a task loop, and that is for structured outputs like, say, an IC memo or a GP report or a report for the auditors, some sort of structured output, and we export into PDF, docx, PowerPoint, etc. The reason we have 2 loops here is partly because Dilla initially started as just focusing on the producing high quality structured outputs and memos, but also because once we flip our agent into task mode, we don't want to be wasting tokens. We don't want to be wasting context on user inputs, on tool calls. We want the agent to follow a set flow with the information that it's got and the context that it's got, to essentially go into overdrive and build the best possible analytical structured output. Elsewhere in the agent harness, we've got model routing for different models, and we use Claude is obviously the best, but we don't use it for everything. The GPT models are actually much better for processing VDRs and legal documents, and we use them a lot. And then we also rotate with open source models for cost, and they really perform not as well as Claude, but they perform similarly to Claude, maybe like 30% worse, but 80% cheaper. So it's kind of a no-brainer. And then we've got all this kind of code infrastructure, context infrastructure of stuff that we're injecting, turn state, so that the agent can understand where it is in the conversation, work on compacting the conversation history, understanding which bits of the conversation history it should use. And yeah, there's lots of clever stuff in here. And I'm going to show you in a minute actually how it works. But really, what we're looking at here is a context management system. Now, you may have heard the word RAG, retrieval augmentation generation. That is essentially what most agents are doing. They are retrieving context and retrieving information from whether it's a data warehouse. It could be from your Google apps. It could be from your Microsoft estate. But generally, the way that agents retrieve context, I've split it up into 2 buckets. The first is a file system. Now, Claude Code and CoWork, this is how they work. They use commands to push through and search through a local file system, so that's on your computer, folders, documents, files, and LLMs are specifically trained on this, so they're really good at it. And then there's the second approach, which is a database. Now, and this can also be a data warehouse for argument's sake. And the way that the agent retrieves context from this sort of structure is via writing SQL to retrieve exact data, and then it feeds it into the LLM, and the LLM does the analysis. And the latter approach is what we use at Dilla. The reason being that file systems create a lot of wastage in terms of the commands. Essentially, the agent can get lost in searching itself around folders, and it can be very wasteful for context and cost. Claude Code and co-work burns a lot of context. We believe that the database or data warehouse approach is far more efficient, and that if you can get the agent to write good SQL, it can retrieve exact numbers, and that's exactly what you want for a regulated industry where the cost of failure is so high. And it means that there's an audit trail, and you can kind of look at the SQL queries and what has been called, what has been retrieved, and it's just so much better for the audit trail that in this sort of industry, the file system approach, in my opinion, is not going to win in the long term, but let's see. Another essential concept, if you are using the database approach, is a semantic layer. Now, this sounds a lot more complicated than it actually is. What it really is in a database, there are many different names for columns, and when you're speaking to an agent, you may not put the exact column name in, for example, such as ARR, annualized, USD, thousands. You may just say revenue. And what a semantic layer essentially is a translation layer between the inputs and the agent and the database fields that allows the agents to get what it needs and write better SQL and understand essentially the nomenclature of the institution, what I call institutional context, and we'll get to that later. And this really matters in a regulated industry like financial services, because 99% right is no better than 0% right. And as I said, I mentioned the audit trail, but it's not just an audit trail. What we actually do in Dilla and what is really required for any agent in a regulated industry is you need an explanation chain, an evidence chain of how the AI got to the steps that it took, and how it got to the tool decisions, and how it got to the final output. And each number can be traceable, backwardly explainable, and also exportable. We export in PDF and CSV so that regulators, and not just regulators, like your superiors, different departments, can see how the agent got to a decision. And sometimes you'll hear this called observability, and it's an emerging field. It's super interesting. We focus on this a lot at Dilla. Another organizing principle of Dilla is we fundamentally believe that LLMs, while they can do maths, and the frontier models nowadays are very good at maths, you should always leave your maths to Python. The reason being that the LLMs will confidently present numbers, they'll hallucinate, whereas a Python pipeline that uses essentially deterministic mathematics, or potentially at a more advanced level, machine learning and predictive analytics and various kind of models and services, you've inherently got that audit trail, and you can trust the numbers and you can trace the numbers. And increasingly, as output becomes a commodity in finance, and defending the actual numbers and the reasoning chain that got to the numbers becomes more important, Python is gonna excel over allowing Claude to run havoc on some DCF. Like, it's going to come up with something that's plausible. It's going to come up with something that might actually be right, but you just can't trust it. And three, it's kind of repetitive of what we said before, the company-wide definitions. So that institutional context of like, what does ARR mean to us? What are the different types of ARR? What was the last audit, for example? So final bits of some of the theory before we get into essentially more of a demo environment. So I've been running automations for the past 2 years at various PE funds, venture funds, and other financial institutions, and I've seen different patterns in terms of where to start, what should be automated, what provides the most value, and what the kind of the low-hanging fruits are, and then what actually takes the most analyst hours, and then what is the LLMs and the agents actually the best at. So you can see on this chart, we've got so high analyst hours is darker crimson, and the smaller the bubble, the harder to automate, larger, easier. And then as it goes left to right, it goes from front office to back office. And I usually tell my clients, start with the back office. The reason being is it's obviously the lowest value work without being disrespectful, but it's the one where the LLM has the highest value. It's the one where the LLM excels the most, whether that's quarterly reporting, fund accounting and valuations, which is where Dilla essentially started, regulatory reporting and compliance. That is where I believe you should start. The next place where you should go is kind of middle office. Portfolio monitoring is one of the best use cases for AI, and it takes a huge number of analyst hours chasing portfolio companies, checking numbers, reconciling numbers. So it's a huge one. And then also kind of managing portfolio companies and that understanding how companies are doing and how that feeds into essentially the exit multiples and the IRR and TVPI, MOIC and stuff for the fund. Super high value. And the LLM is really good at it, alongside using special Python and domain knowledge to do it. Now, most of the clients that I speak to, the highest value tasks that they want to automate, or that not necessarily that they want to automate, but they want something for, are front office activities, deal sourcing, writing the investment memos, LP communications. That's actually a mistake. I would say that's middle office, and it's also a really good use case. But yeah, Dilla is 100% focused on these two things: IC memo and deal sourcing. I will say though that I would not get rid or forego of creativity here and judgment, because the LLM may tell you that you should invest in accountancy roll-ups, but you yourself as a practitioner know that the space is crowded, there's a long-term threat from AI on the billable hour, and that maybe it's better to go into law instead, for example. And also with deal sourcing, I'm going to show you some really cool stuff with the sourcing agent that we have in a minute, but it is fundamentally about data. It's about data. And it's fundamentally about network as well. So, but with agents, you can really help sourcing not just companies and building lists or building buyer lists if you're an advisor. We'll go into that in a minute, but it can also help finding advisors, law firms, the kind of places where you actually find the deal flow, or potentially peer funds, investment banks, boutiques. So yeah, there's a huge scope for automation. And then of course you've got finally like that data hygiene piece. And one of the biggest pushbacks that I get is people tell me like, oh, well, there's no point adopting agents because all it will tell us is that the data underneath is messy and that we need to improve our processes. Sure, that can be a thing, but usually that is just an excuse for not adopting AI. And there are many ways also that you can use agentic systems to actually help with your CRM and data hygiene. And Dilla integrates with your CRMs and full Microsoft estate, such as CRMs such as Affinity, Attio, Salesforce, and also a lot of your HR systems, ERPs for accounting data, and also with email, Outlook. So yeah, there's a lot that can be done there. And if someone tells you, that, oh, it can't be done because the data's messy, it's an excuse. Similarly, on the sell side, kind of similar patterns in terms of, you know, pitch book creation, notes, earnings analysis. That's really with a kind of public markets vantage point. Where I'm probably looking at more is looking at M&A and kind of getting those sims right, understanding cap tables, of course sourcing, but buyer list too, and then again, similar pattern with the buy side. You've got all these kind of middle office and back office tasks, such as onboarding, KYC, regulatory, reporting, settlement, which there's huge scope for automation and agentic work. And then finally, just a little piece on modeling, because it's often shown as a prime use case. Again, yeah, LLMs excel at this, but they also make a lot of mistakes. So, I mean, if you're just using, say, Claude in Excel, it's gonna come up with something that looks really impressive. But if you dig behind the numbers, be very, very careful presenting that to someone above you or a client, because it's gonna be full of errors. So, like, what does this mean for the human without going too meta? The way I think about it is, in the age of agentic AI, a human is going from individual contributor to idea generator and content reviewer, which collectively is quality assurance. The models postulate. They create plausible arguments. They create plausible formulas, plausible discount rates, for example. But they don't know the essence, the gestalt of the actual data. So that's your job ultimately. And in the age of agentic AI, your role is definitely going to shift from building materials and building outputs to prompting and shaping outputs and reviewing them and improving them, and seeing where the model is writing slop, basically, and refining them. And like, what is that going to mean for employees? It's going to mean more companies covered, more markets covered, or fewer markets covered, but markets covered in more detail. And ultimately, it is going to mean more fun. Like, I sometimes use Dilla for fun. I know it sounds ridiculous, but you will have heard of the frame vibe coding, but vibe using is definitely something that is fun, and it's going to remove a lot of admin from your life. And sure, there's going to be a lot of job displacement, but I personally think that it's going to create a better industry. So let's just get into what actually is an agent, and then I'll show you the Dilla agent. So there are two main frameworks for agents. One of them, which Dilla uses, is a reason act loop. So you'll have one LLM that's a reason prompt, and another LLM that is an act prompt, and they loop between each other. They loop the outputs and inputs between each other until the task is completed, and then it produces the output. Plan and execute is another variant that has known to be very good for mathematical tasks, but it generally is purported to have worse performance. The agent creates a plan, generates a task list, executes each step, and we do have elements of that in Dilla, as I mentioned. So let's get into it then. So enough talking. Let's show you what Dilla's really about. So I'm just going to get rid of that one. So say you're a portfolio manager at a fund. So tell me, so let's say, run some fund level analysis on my fund. And let's see what it comes up with. So as you can see, it's running all sorts of specialist tools for this task. Let's see what it comes up with. So it's come up with some charts. We're really looking for some detailed exit analysis. So let's see if it comes through. So here we have some of the stuff. It has failed on some of the charts. However, it's really got to the, I mean, it's not got the IRR because we don't have time series data, but it's come up with a NAV. It's come up with an implied MOIC, DPI, TVPI. It's got concentration analysis and kind of portfolio health signals. It's got implied entry valuation. So this is really good analysis. It's showing risks, data gaps, and kind of estimating and running some calculations on the NAV by stage, by sector. And then it's suggesting some potential outputs of what to do next. And of course, for the audit log, we've got a full history of what each thing did. So look, if you go into the individual thing, it shows that there was an error in one of the services. And we can export this, which is perfect for the regulators, as JSON. So this is kind of, and it's created some updates which you can accept and upsert into the grid, which is really, really cool. So let's, and it's come up with, yeah, so a ton of suggestions. Let's hide this. Okay, so this is portfolio management. Boring stuff, but it's cool. But I know that everyone really cares about doing deals front office, so let's shift our minds to sourcing, and ultimately sourcing is where the rainmakers make money, right? So let's ask it to so let's go with something vague. Find me non-tech companies in the lower middle market in the Midwest that benefit from the AI CapEx boom. Now it's going to be coming up with searching strategies. It's going to be trawling the web, finding entities, reorientating itself, seeing if it's gone down a rabbit hole and it's maybe not the best place. And let's see how it thinks about sourcing these. So that's failed, but it's retrying. And essentially what it's going to be doing is coming up with search queries and search strategies of like, where might you find these companies? What sort of signals may identify them? And one of the main problems that LLMs face in retrieving structured data from the internet is LLMs do not understand how humans use search engines. They don't know how to construct a search query. They just don't search in the same way that humans do when they're doing research. And it's a real problem. It's something you really have to train into the models of like how to find companies, how to search for stuff. Okay, so it's corrected itself with the planning. Hopefully it's going to fire off some. Hopefully it's going to fire off some queries. Interesting. So it's looking for fiber installation, electrical testing. Super interesting. It's using a lot of Boolean search. Boolean search, by the way, is when Boolean search is when you use kind of structured inputs into your search queries, like say LinkedIn.com or acquired or recapitalization. It's kind of like keywords. It's very useful for finding LinkedIn profiles without actually using LinkedIn, which is heavily blocked with anti-scraping. Okay, so it's come back with some companies and a thesis. Category 1, electrical contractors and switchgear. Target profile, it's found some companies and why it's relevant. Category 2, specialty cooling and mechanical. Category 3, transformers, switchgear and power distribution. Category 4, electrical testing. Category 5, concrete, civil and specialty construction. Category 6, fiber and low voltage cabling. Category 7, specialty materials and industrial supplies. So it has found many companies. It should have added them to the grid actually, but that'll be something that I saw. But yeah, it's done a really good job. It's done a really good job. I'm impressed. And yeah, so that's our agent. We have a couple of other. I mean, I may as well. I've got a bit of time. May as well show you some different features. We have P&L mode, which is it's really. Let me go in a different fund actually, because this is a different module. So P&L mode is about going really deep for private equity into the financials. It's essentially an ERP of sorts. It connects to an ERP. It does forecasting automatically. It reconciles any ERP format. So let's get rid of that. Let's get rid of that and let's ask it, tell me about some model routing strategies I should pursue and what financial impact they would have at current token prices. So let's see what it does here. Probably the wrong search queries, but let's see. Let's see where it's going with this. Okay, so it's okay, that's not relevant. It's fetched the current spend, and it's come with some strategies and potential ROI and sensitivity and savings by routing to other models. And it's run some analysis on the kind of unit economics and inference economics of the company itself, Lovable, one of its subsidiaries. And of course, we've got how I got here. So yeah, so again, this is more something that you could adopt at fund level or on the sell side by going deep and analyzing into the company's raw financials and reconciling them. Or you could adopt this at portfolio company level when thinking about adopting AI, cost routing, or just general Office of the CFO activity, FP&A. So yeah. But yeah, so I'm going to finish up on the demo, and finally, I want to end on some final words. I think it's really important for finance professionals to recognize that over the next 18 months, firms are going to get agentic. They're going to have to stay competitive, and you as an employee will have to do the same. You're going to have to become more tech literate. You're going to have to play around with agents. But let's not forget, while English may be the new programming language, agents are still software. Software requires maintenance, experimentation, and infrastructure. In the early 2000s, investment banks built their own order execution software to stay competitive. Right decisions strategically, but a cost sink and technical debt in the long run. It can be very easy to get overconfident about what we can build with Claude. You may even go home and ask Claude to build a script that solves a problem that you're facing on day to day. Or maybe you'll go on a visual builder like N8N or Zapier and build an automation chain. This is super important for your own development, but don't get distracted. You are finance professionals who are paid for your understanding and dealing in markets and securities. We always put quants on the trading floor, but we never let the trader build his own algorithms. We did have him or her involved in the feedback loop of getting those algorithms that the quants built right. Do you buy at the core, or do you build at the core or buy at the edge, or buy at the core and build at the edge? Both can work, but one thing is for sure, you will be both buying and building a lot of software that isn't just direct tokens from Anthropic. Tokens are going to gradually fade into the cost of goods sold of any business over time, but they'll be resold, tinkered with, managed, and deployed, and experimented with and tested. These are important principles. I hope you've enjoyed this session. I hope you enjoyed looking at Dilla. And any questions, feel free to reach out. I'm on tal@dilla-ai.com, or you can contact me on LinkedIn. Thanks so much for taking the time to listen, and hope you guys have a great week. And yeah, let's build.